This video is part of the Pre-Calc 11 trig unit. This particular one is just meant to act as a review of all the trig that you would have done in grade 10. I'm recording it and putting it at the start of the unit, but it's probably best watched just before you watch the 2.2.1 video. So you can do the first couple of videos on 2.1, and then once you've gotten through those, this is probably where you're going to want to watch this. So, grade 10 trig. Just to set up a couple of things before we get going on the actual trig things. Some reminders on how things are labeled and written. So remember, all the trig that you did in grade 10 would have been with right triangles. Something like this. And when you're dealing with right triangles, well, you've got three sides. One of your angles is going to be 90 degrees. And we've got three sides and three angles, and we label those sides and angles in a consistent way. The letters themselves don't have to be consistent, right? You can use A, B, and C, you can use P, Q, and R, it doesn't really matter, whatever, it's up to you. But angles and sides are labeled differently and kind of in a related way. So if these are angles A, B, and C, our angles are always labeled with uppercase letters, as I've done here. Our sides are labeled with lowercase letters. And beyond that, there's also a connection between sides and angles that use the same letter. So if this is angle A up at the top here, side A is always going to be across the triangle from angle A. So if I go across from there and I land here, that's going to be side A. If I do the same thing at side B, I'm going to land over here, and then side C over here. So opposite sides and angles use the same letter. And that is something that people tend to mess up, and it is going to be super relevant for some of the things that we do in this chapter, because some formulas that you're going to learn are going to use the letters A, B, and C in ways that you have to know which things connect with other things. So try to get that down now. Opposite sides and angles use the same letters. Beyond that, your right triangles that you're working with in trig have three sides with three names. So when we're relating these three sides, we want to be able to distinguish them. And so we have three different things that we call them. One of them is always going to be consistent, and that's the hypotenuse. So the hypotenuse is the longest side, and it's always across from the right angle. So you can see on this triangle, I drew a little dotted line going across from the right angle to get my hypotenuse. The other two sides are dependent on which angle you're looking at. So if you're focusing on this angle here, and we'd call that maybe theta. So if you don't remember from last year, theta, that little circle with the line through it, is a Greek symbol, and it's just sort of like your generic variable for angles. So if we're focusing on angle theta down there, if I go across the triangle from theta, I get my opposite side. And then the third side, which is next to angle theta but isn't the hypotenuse, is called the adjacent. So those are your three sides: your opposite, your adjacent, and your hypotenuse. Relating those three sides, we've got three ratios. So we've got the sine ratio, which is the opposite divided by the hypotenuse. We've got the cosine ratio, which is the adjacent over the hypotenuse. And then we've got the tangent ratio, which is opposite over adjacent. There are other ratios that you're going to cover in grade 10. So these are called the three primary trigonometric ratios. Right, so you'll learn later about things like cotangent and cosecant, but don't worry about those. So to make this a little bit easier to remember, right, if we boil these down to just the key letters, we've got sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent opposite over adjacent, and so you probably remember from grade 10 this handy little memory device, SOH CAH TOA. So remember, that 9-letter combination tells you exactly how to set up your trig ratios, right? Your first letter is the ratio, the second letter is what goes on top of the fraction, and the third letter is what goes on the bottom. So cosine is A over H, tangent is O over A, and so on and so forth. So let's try putting this to work. So I'm going to give you a triangle, And from that triangle, we are going to write our sine, cosine, and tangent ratios. Keep in mind, there's a difference between a ratio and an angle or a side length. So if I ask for a ratio, or if you ever see somebody talking about a ratio, they're not talking about the size of the angle. They're just relating the sizes of the angle or the side lengths in the triangle. So let's say we were looking at angle theta up here, and then this side was 5, this side was 12, and this side was 13. When you're doing trig, particularly grade 10 trig, the way you're going to want to start things typically is by labeling your side lengths based off of which angle you're looking at. So from the perspective of angle theta, 13 is our hypotenuse, although that's always the hypotenuse no matter which angle we're looking at. And then 12 is our opposite, and 5 is our adjacent, right? So you go across the triangle to 12, which makes it your opposite. So to do our trig ratios, we're just going to fill in these three fractions using the appropriate side lengths. So sine of theta, right, the sine ratio for angle theta is our opposite over our hypotenuse, so 12 over 13. Cosine theta is adjacent over hypotenuse, so 5 over 13. And tangent is opposite over adjacent, so 12 over 5. But the main thing we actually want to know about is calculating angles and sides. So the ratios are useful, but typically are just kind of like a stepping stone along the way to something else. So let's see how we can calculate some angles to start. So let's say we had this triangle, and we were asked to determine theta. All right, so looking at this, if our angle theta is down there, there's sort of a couple of intro steps that we want to do, and these are things that can happen in your head, but it's not the worst thing to do them on the page. So we're going to start by labeling. So that's just your O, A, and H. So from the perspective of angle theta there, 10 is my opposite, our hypotenuse is down here at the bottom, and 17 is the adjacent. So our second step, having done that, is going to be to pick a ratio. And the way we do that is we just pick whichever ratio fits the information that we're dealing with. So in this case, we don't care about the hypotenuse because we don't know it, but we do know the opposite and the adjacent. So if we go back to SOH CAH TOA, which I'll just write down up here, if we're dealing with O and A, that is the tangent ratio. So tangent theta is O over A. Once you've picked a ratio, you're just going to plug in all the numbers that you can, whether that's side lengths or angles. So you fill in what you know. So in our case, we don't know the angle, so we're just going to leave it as theta, but the opposite is 10 and the adjacent is 17. From there, to solve for our angles, we're going to use inverse trigonometric functions. So this is where you're going to need to have a scientific calculator, and you're going to need to know how to use it. So it's really important to have your own calculator that you're familiar with, because if you're not, you might bounce around not knowing which button is which and how to get them, and you might do things wrong. So you always want to try to have your own calculator so that you're familiar with it and you can use it effectively. All right, so our three inverse trig functions are tangent -1, sine -1, and cosine -1. And you just use whichever one is related to the ratio that we're dealing with. So in this case, we're going to use tangent, so we're going to work with tangent -1. And so we would never really go through and actually write it this way. But what tangent -1 is, inverse tangent, is it's just the opposite of tangent. It's like adding versus subtracting, squaring versus square root, whatever. So if you did tangent -1 on both sides of this equation we've got here, the tangent and the tangent -1 on the left would cancel out, and you would just be left with theta, the angle that we're trying to find. On the right, you've got tangent -1, inverse tangent of 10 over 17. And so that's what you're going to want to put into your calculator. So to get to tangent -1, most calculators, you're going to use the second key or the shift key or whatever, it's typically located in the top left corner of your calculator. And then you're going to press, generally, the tangent button. So on most calculators, you'll see a button that's labeled tangent. And then in the little text in a different color, it might be yellow, it might be blue or green, above your tangent button, you'll see a little thing that says tangent -1. And so if you do shift and then you press tangent, you'll get your inverse tangent. The other thing to make sure is that your calculator is in degrees. So you don't want to see a G or a grad or an R or a rad at the top of your screen. These are bad. What you do want to see is a D or a DEG or occasionally a DRG. Those are all good. So the gradients and radians are things you're going to use in Pre-Calc 12. So for us in Pre-Calc 11, you definitely want to make sure that your calculator is in the right mode. So double check that. And if you don't know how, talk to a teacher, get some help setting your calculator up. All right, so if we go to our calculator and we do tangent -1 of 10 divided by 17, and we get an answer, it's going to be about 30 degrees. So for me, with angles, typically I'm going to round to just the nearest whole number unless I have a reason not to. So let's try another one. So you're going to determine angle M in this triangle. So this one's going to be for you to try. Just follow along with the same thing we did in the last one. So you're going to label some sides, pick a ratio, plug things in, and solve. And do make sure that you're doing the right ratio with the right angle. So go ahead, pause here, and try it on your own. Okay, so looking at our triangle here, 101 is the opposite from angle M, right? So angle M down here, this is the one that we're working with. 137 is the hypotenuse. And so if we're working with O and H, that means we want to be working with the sine ratio. So sine theta is the opposite over the hypotenuse, right? So if we start plugging in things we know, so we don't know theta, but we do know it's angle M. That's the angle we were asked to find. The opposite is 101. The hypotenuse is 137. And so to get angle M, we're going to do our inverse sine of that ratio, 137 or 101 over 137. So if that's what you're going to plug into your calculator, and when you do that, you should get 47 degrees. So working with the same triangle, you might also be asked to figure out the other angle. So determine angle N. And so you could go through and do like a full trig question with this. You'd be working with cosine and doing cosine of 101 over 137 and all that. But there's actually a faster way to do this. So a quick reminder for you, something that you should have learned in previous years. Triangles have a very helpful property, and that is that all of the angles in a triangle always add up to the same number, specifically 180. And every shape kind of has that property, but it'll be a different number for every other shape. So rectangles, octagons, whatever, they all have their own thing that they add up to. But we work with triangles most, and so we need to know that triangles add up to 180 degrees. And so if you know two of the angles in a triangle, which we now do, so we know our right angle up here, which I forgot to label, right? So we know this one is 90 degrees, and we just figured out that M was 47 degrees. So to get our third angle, all we do is 180 minus the two angles that we know. So minus 90 minus 47. Some people prefer to add the angles they know together first and then subtract. So you absolutely could do 90 plus 47 to get 137 and then subtract, or you can just subtract all at once. And when you do, you should get 43 degrees as your third angle. So that's a really helpful thing to remember. It can just save you some work down the line. And in some cases, you are going to need to use that before you can do anything else. So that's calculating angles. Now let's calculate some lengths. This tends to be a little bit more challenging just because there's often a little bit more work involved, but it's not that much worse. Before we get to trig, though, there is something else that we're going to want to remember, something else that we are going to use at several points throughout this chapter, and that is the Pythagorean Theorem. So if you have a triangle like this, where you don't know any angles, and you want to get a side, so you know two sides, you want the third. You could use trig to figure out an angle and then use the angle to figure out a side, but that's lots of steps that we don't need to worry about. The fastest way to do this is, of course, just the Pythagorean theorem. Remember, the Pythagorean theorem only works for right triangles, so don't ever try to use it for anything that's not a right triangle, and we will deal with triangles that aren't right triangles later in the chapter. So it's good for the right ones, not good for anything else. Your Pythagorean theorem is a squared plus b squared equals c squared. Remember, c has to be the hypotenuse. A and b, totally interchangeable. C has to be the hypotenuse. And don't focus on the letters, focus on where they are in the equation. So if we plug this in, A, we can make it be 6, B is going to be 8, C we don't know. So 6 squared is 36, 8 squared is 64, 36 plus 64 is 100. And to get rid of that square, we're going to square root both sides to get us that C is 10. Thinking back to some of the stuff we did in chapter 5, or chapter 4 even, technically when we square root both sides here, we should be considering plus and minus, right? But the thing is that we're dealing with physical lengths, so there's no way for it to be negative 10, so we don't actually have to worry about the plus or minus, but it is something to remember it exists. All right, one more Pythagorean theorem question, but from a slightly different perspective. So if you knew these two sides, and you were asked to find that side, if we write out our Pythagorean theorem, right, a squared plus b squared equals c squared, remember c has to be the hypotenuse. So in this case, we know c. So if we go a squared plus 14 squared equals 18 squared, and we do those multiplications real quick before we worry about anything else. So 14 squared is 196, 18 squared is 324. So now we've got to do something a little different because we can't do 196 plus 324. That doesn't really make sense in this context. What we do need to do instead is to solve for a. So we want to move that 196 to their side, and we're going to do that by subtracting. And so you end up with a squared equals 128. Then we're going to square root both sides, and we end up with a equals root 128. I will say, you could do mixed radicals in the same way that we did in several chapters in this course. And so you could turn this into 8 root 2. Your textbook will probably do that at various points, but I will say for me personally, in this chapter, I don't care much about mixed radicals. There might be one or two cases where I talk about it and bring it up, but by and large, we're not going to worry about mixed radicals. We will leave stuff as exact values on frequent basis, but unless there's a good reason to, don't worry about it. But sometimes we will want a decimal answer as well. So if you plug root 128 into your calculator, you'll get 11.31. And so that's Pythagorean theorem, but that's not the only way that we calculate lengths. Obviously, we have trig as well. So let's look at an example. So let's say we had this triangle. And we knew the following things. So I told you this was 25 degrees. And this was 11, and this was x. And so I want to calculate that hypotenuse. So the first thing we need to do, again, is label. All right, so again, this is trigonometry. So we label. So you got to decide which side is which. So from the perspective of our 25 degrees, 11 is our adjacent, and x is our hypotenuse. Once you've labeled, you pick a ratio. So it's the same first steps, whether you're calculating angles or side lengths when it comes to trig. So if we want a and h, that is going to be the cosine ratio. We plug in numbers. So again, same steps as it was when we were calculating the angles. But after this, it is going to change. So our cosine ratio, cosine theta. But now it's not theta because we actually do know what that angle is. We have an angle, it's 25 degrees. Our adjacent is 11, and our hypotenuse is x. So now we're ready to calculate x. So here's the thing. Keep in mind that cosine 25 is just a number, right? It has a value. cosine of 25 is about 0.9063. And so we treat this just like we would any other number. If I asked you to solve, I don't know, 4 equals 8 over x. This is just a proportion. And we can solve proportions in the same way we've been solving them since grade 8. So if I asked you to solve this thing, remember you could probably just throw a 1 under the 4, and then you would cross multiply these things. And that's what we're going to do here as well. So our next step is to cross multiply and solve. So in our case, again, we're going to leave cosine 25 as cosine 25. We're not actually going to turn it into a decimal, because if we turn it into a decimal, it's just going to be annoying to work with. So you can throw a 1 underneath it. You're going to multiply your diagonal things. So we're going to do x times cosine of 25. And we're going to do 1 times 11. And now we want to solve for x. But remember, cosine 25 is just a number. So if you had done this with the one we've got in the corner here, right, 4 times x would have been 4x. And you would have had 1 times 8. And so if you wanted to solve that for x, you would just divide both sides by 4, right? So you're going to do the exact same thing here. Cosine 25 has a value, so we're just going to divide both sides by cosine of 25. So on the left side now, we just have the x. On the right side, well, 1 times 11 is 11. And so we've got 11 divided by cosine 25. And that is what we want to do in our calculators. So again, do it really carefully. If you plug that in and see what you get, you should end up with x is 12.14. So for me, I mentioned that angles, I usually go to just a whole number. Side lengths typically are going to go to 2 decimal places. All right, so I'm going to give you one more of these to do, and then that is going to wrap up our trig review. If you feel like you need a little bit more practice, go ahead and check out the Foundations in Pre-Calc 10 videos on my channel if they're available, and you'll be able to just go through the entire trig chapter and watch a little bit more of whatever you feel like you need to focus on. Otherwise, you're always welcome to ask questions as well. So if we know this side is 52 degrees, this side is D, this side is 91 millimeters, and I want you to figure out D. Go ahead, pause me now, and try your best to go through this question. All right, so D is my opposite, 91 is my adjacent. O and A is going to get me the tangent ratio. So tangent of 52 equals my opposite over my adjacent. We throw a 1 underneath that, and then this one's actually going to be even easier when we cross multiply it. So we've got 1 times D is just D. And on the right, we've got 91 times tangent of 52. So on the left, 1 times D is done. On the right, if you do 91 times tangent of 52, you're going to get 116.47. And then don't forget your units, which is millimeters. And so there we are. That's how you get angles and side lengths using both trig and Pythagorean theorem where needed. So these are all valuable skills to have in this chapter. We are going to do a bunch of other stuff that doesn't necessarily use them, but there will be lots of times where we come back to this. So definitely make sure that you're feeling pretty comfortable with it. Once you're ready, feel free to dive into some of the new stuff.